Now we are moving towards some applications of the fundamental theorem, and you know that fundamental theorem says f dash of x dx is equal to f of b minus f of a. Now the first application is, if you want to calculate the displacement and the distance. So if in general, if you want to calculate, and I am saying s is the symbol used for the distance, then on the right it will be something like s of b minus s of a, the distance at the final point minus the distance at the initial point. So what should be inside the integral? So whatever is this, here it was f, so inside the integral f dash. Here it is s, so inside the integral should be s dash, depending on x, t, whatever things is, the variable is. Now, either you will know this thing, which is the derivative of the distance function, or in the question you will be given a velocity function. So if you are given a velocity function, you know that velocity is the derivative of distance function. So sometimes they give you a velocity function and they ask you to find the distance traveled by an object. So now you will be worried how to know the distance, but you know this formula, that velocity is what? It is the derivative of d by dt of s. And when you put this guy here, the fundamental theorem of calculus says that the simple version of this at the point b minus a is your answer. So you can use it. So if you are given the velocity, now you should not be worried that how to find the distance, because velocity is equal to the derivative of distance, and that is what you need here if you want to apply the fundamental theorem. So one thing you should keep in mind, that whenever somebody will ask you to find something using an integral, then it means they are going to give you a derivative of that thing in the expression. If they wanted me to find x cubed by 3, then, but they didn't give me this expression, they wanted me to find this, but they give me an expression x square dx. So it means the original function is this, and they gave me a derivative of this function here. Now in the question, if they want you to find the distance, then in the integral it will be a derivative of distance, and you know that a derivative of distance is velocity. So either the function will be given like s dash of t is equal to something 2t square plus 1 blah blah blah, or they will give you v of t is equal to the same function 2t square plus something. So both are equal. Velocity is the derivative of distance. Similarly, if they want you to find the change in velocity, vb minus va,
acceleration,
then what will you, they will give you an acceleration function in this expression. So you are going in the forward direction. If you are given the first derivative, now this is what? This is the first derivative of the distance.
So it's just for understanding, but we don't really have to change anything. It's the same thing.
Yeah, you don't need to change. But I am telling you that whatever they will ask you to find, it means they have to give you a derivative of that thing.
Derivative.
That's it. So the question is, here we have a distance problem, simple problem.
Okay.
Question says, suppose a car is moving due north, car moving towards north, and he says the north is the positive direction, means the plus distance, and the speed is at the velocity 40 miles per hour in between the time 2 p.m. to 4 p.m. Then after 4 p.m. the car starts moving towards the south. Now the north was positive and south is negative direction. And the speed is 30 mile per hour in between the time 4 p.m. to 5 p.m. So a car started traveling at 2 p.m. but during those 2 hours from 2 p.m. to 4 p.m. it was moving with this speed 40 miles per hour towards the north, which is a positive direction. When after 4 p.m. it started moving towards the south, the direction is changed and the velocity v is 30 miles per hour, and that this is the domain. So you see, these guys are the intervals, the limits, and this guy is the function. The question is, two questions: find the displacement, find the total distance. Now there is a difference between displacement and distance.
Can you explain the problem again? I didn't understand.
There is a car and it started moving towards the north from here, and the time here was 2 p.m. The car started moving. The very first speed velocity was 40 miles per hour, and the same velocity it keeps up till 4 p.m.
Okay.
Somebody has sent me a leave. Chaudhry MD Asadur Rahman. Keep it in the record, Huzaifa.
Okay, it's today's because yesterday he's sent.
The date is 8 March.
Okay.
I'll send it to you. You can check. Okay.
Okay, thank you.
The car is here. This is the initial point, and the time is 2 p.m. Car started moving towards the north. This direction is north, and I'm saying this is the positive direction, which is like whenever you are moving on the x-axis, if you are moving like this, then this is the positive direction, this is the negative direction. If you move like this, so it will be negative direction. If you move like this, it will be positive. So the car is going like this, and it is a positive direction. 2 p.m. to 4 p.m. it stayed there. Now there is a U-turn, something like this, and after that, at that U-turn, this velocity is 40 miles per hour. From here, the car took U-turn, whatever the direction, wherever it is going, this 4 p.m. and somewhere here, this is 5 p.m. time, 4 p.m. to 5 p.m. and the velocity was 30 miles per hour. So the car started from here and traveled this distance at this speed up till 4 p.m. Whatever the distance is, we have to find it. But it traveled up till 4 p.m. from 2 p.m. and this was the speed. Here it took the U-turn and then it traveled towards the south with the speed 30 miles per hour up till 5 p.m. So the given data is
Okay.
the speed of the car and the time lapse, the interval of the time
Yes.
in between these two time intervals. So the given data is speed and time. The question is find the displacement and find the distance, total distance.
Okay. Right.
So when you find the displacement, you just need to add up the positive and negative, whatever the answer is. But when you find the total net distance, it means you will consider whether it is negative or positive.
Yeah.
You will add them together and you will tell me, yes, the car actually traveled, for example, it traveled 50 meter in the positive direction and 30 meter in the negative direction, then displacement means 50 minus 30, 20.
20.
But the total distance means 50
80
plus mod
plus.
of minus 30 means the positive of 30, whatever it is. So the total is
Okay.
80.
But why mod? Why are we using mod?
Because that distance, that direction is negative. So we use the mod, that absolute value of 30. Whenever you are considering something negative to be added as a positive thing, you say that yes,
Okay.
the absolute of this number, whether it is negative or positive, the absolute makes it positive. If you have
Okay,
negative
right.
30, the answer
Like
will be
when
30.
we need positive, but actually that's
Yes,
negative.
actually it is
then
negative, but we need an addition, positive addition to get the total
Right.
traveling. So
Right.
we take the absolute. So this is the problem and the data. So we have the intervals. Now I told you that when you are supposed to find the distance, displacement, all these guys are same thing. They are represented by S. So it means
Yes.
on the right I will have something like S of B minus S of A. But on the left I will
Okay.
have the formula, which is integral, the given data. Now the given this,
Okay.
if this is the distance, then on the left I am given the velocity of t at dt. So I don't need this thing. This is the solution which I will get ultimately. I need this expression to move on. So what will be this expression? You see, there are two time intervals, 2 to 4 and 4 to 5. So we actually have, you can say that we have two integrals. The first one is from 2 to 4 and the second one is from 4 to 5, right?
Yeah.
Total time is, okay, total time, traveling time is, they started at 2 p.m. and they finished at 5 p.m. But in between, from 2 to 4, there is one direction,
4 to 5.
and 4 to 5 there is another direction. So that is why we have splitted the total interval into these. You can see these limits should be same when you split an integral, and we have solved an example previously where we said the total integral is, okay, let me write here, the total integral is from 2 to 5. The total traveling started here, ended here at 5, started from 2. I am going to split it into two parts, the positive and the negative. So it becomes 2 to 5, 2 to 4, the velocity function
4
dt,
to 5.
plus 4 to 5, the same velocity function into dt. Now
So
I
if
know,
they both will give the same answer.
no, the limits in this, these are the different data. The function formula will be the same, but for them the data is different. I will tell you the next step. Now from 2 to 4, you see the velocity
No,
is,
not between them. I mean, if we split them and if we like completely like from 2 to
no,
5.
you cannot do this because you
Okay,
have to
okay.
split them because here the number is positive, here this number is negative.
So behavior is changing.
Yes, behavior is changing, you have to split it. The total is this, formula is okay, but you have to split it. If they did not talk about the direction and they just said, okay, the car started traveling at 2, ended at 5, give me the distance, no need to split. But because of the direction, you have to split it. So
Right.
now 2 to 4, this thing they gave you here, it is 40 dt, plus from 4 to 5, this thing is 30, but what should be the symbol?
What?
What should be the symbol of 30? I told you when it is moving towards north, it is positive. When it is moving towards south,
Yeah.
it is negative.
It's negative.
So
30
this
negative.
integral will involve a negative. You have to involve it yourself. Here they didn't give you negative. Here they just write the speed. Of course, the velocity is never, you never say that the car is moving with negative 30 miles per hour. It is always a positive number, a positive value, but you have to figure it out whether it is positive or negative from the direction. So which one is your positive? If it will move towards the negative, then you will have to add the negative direction. So now you can solve it simply. It is 40t.
Okay, one more question is coming in my mind.
Yeah.
From the previous I asked.
Minus.
Like we split it because its direction is changing. Okay, and you told if it doesn't talk about any change, then we don't need to split. So my question is, if direction is not changing, it's going in the same direction, but after the 2 hours from after 4 p.m. the speed is different from previous, so then we will split.
Yeah, if speed is changing, two things. We split it because speed is changing. We are not splitting it because direction is changing.
Okay.
We are splitting whether, okay, if you have, for example, it is moving in the same direction, but this part the speed is 40 and this part the speed is 50, then you will split it from here to here separate, from here to here separate.
Right.
Because you are going to put these values into the function. Now you never know if you take the whole interval from, for example, 2 to this 5, and in between 4 to 5 these are two values. Now if you keep one function and you don't split it, now which value you will use here, 40 or 50?
Right.
So you have to split it so that you can use 40 for this interval and use 50 for the, so as many intervals for the speed, as many times you have to split it.
Right.
Now if you calculate this will be something like, and the solution is 80 minus 30, so it is, the answer is 50. Now this is what? This is the distance, displacement from this position, the displacement of the car from this position. Yes. After this total time interval. Now the second question is, what is the total distance traveled by the car? This
you will put mod.
Yeah, so you will just apply the same thing, but here you will apply the mod, and when you apply the mod, the negative becomes positive, this becomes positive, so it will be 110. So 110 is the total distance traveled, and 50
and 80.
50,
okay, 50, yeah.
50 is the position of the car at 5 p.m. from this point. The position of the car, if for example, if the car went there and then moved, because it is taking a U-turn and coming back, and we are ignoring this U-turn distance. This is delta x. We ignore this.
Yes.
We do not count.
I understand.
When it takes the U-turn, definitely it is going towards the west or east, and we assume this is delta x, and we say this is approximately 0. We just took the U-turn and came back. Now when it came back,
take a U-turn, just put the reverse gear and go.
Yeah. So we assuming that it didn't take any distance towards the north, towards the east or west. So when it came back, now this position, this was the starting point. So the answer 50 is this, from here to here. This is the in between shortest distance between the position of the car and the starting position. So it just removed this part here in the negative. But when you will talk about the total distance, it means you are going to add this distance, which was 80, and you are going to add the reverse distance, which was 30. So you have got total distance 110. But in that case, you did the different thing.
We don't consider in the like west or east direction, because then we will have to consider that distance as well.
Of course. So we assume that it didn't move. We assume that is the delta x, and we say that delta x approaches 0. So that is the margin of error in your total distance.
Yeah.
You can see, if for example, you can apply this practically. You are going on the car
Yes.
and you calculate the distance, and at a certain point, you just take the U-turn.
Yeah.
There will be a distance when you are taking the U-turn.
Yes.
Whether it is
4-5 meters.
whether it is 0.1, 0.2 something meters.
Yeah.
You will see, if you calculate, if you watch the reading on the meter of the car closely, you will see this answer, and the meter reading will give you a marginal error. That error is coming because of the U-turn, the delta x, which you said it is 0, but it was actually not 0.
Right.
Similarly, if you want to know about the change in volume, the same problem, I'm going to write it, and I expect you guys to try it. Same procedure, but this time it is the volume. I'll write the necessary expressions for you. If motor on a motorboat, if the motor on a motorboat is started at the time t equals to 0, and the motor consumes gasoline at the rate of 5 minus t cube gallons per hour, how much gasoline is consumed after 2 hours? And you don't need to convert the hours into minutes, because this thing is given in hours. If I give you this thing in minutes, then you can convert these hours into minutes. But here, everything is in hours, so this is okay. So, what is the time interval? Starting from 0, ending at
0 to
2 hours. So, this is the interval. And the volume of the gasoline is given to you at the rate, the volume at any given t is changing at this rate, gallons per hour. How much gasoline is consumed? So when the quantity is changing in terms of the volume, then how much means you have to calculate the total volume consumed by the motorboat, by the motor in 2 hours. So you have to give me the change in volume. What should be the formula? It will be something like integral the change in volume dt, and on the right, you know, the volume at the time t2 minus the volume at the time t1, right?
Right. Yeah.
And on the right, this guy is just giving you the situation, what will be the answer. So you need an expression for this guy, just like we did in the case of the distance problem. Now for this guy, what will be the inside the integral? The motor consumes gasoline at the rate of this. It means the volume is changing at this rate. It means V dash is this guy. So you have the expression. Now put this expression, apply the limits, and give me the answer.
I mean, consummation of both hours, not only.
I
mean, we are talking
Zafar.
about the total interval, not
No,
only
no,
the
no, no,
1
no.
hour.
No, that is you're right. But I want to know. Okay, let us do this. When I am solving this 0 to 2,
Yeah.
we solved it. We solved this guy.
I think it's something with the definite interval. I think it's.
Look, we solved this guy and we got the answer 6. This should go on
Yeah.
with every step. This is not changing. This is a unit.
Yeah.
The unit will go with every
Yeah.
step, and finally here, this will again come up here. But
Okay.
you gave me the answer 6 gallons. I am telling you 6 gallons per hour. Either you justify me that why you removed this hour, or I can tell you where this hour goes.
It's something related to like.
Yeah, think about it, you will get it. Just think about this whole expression. Think about the units of all the quantities here.
Because
The answer for this is 6.
we're
Now look.
taking.
Look. The unit of this expression is gallon per hour. So let me write it here, gallons per hour. What is the unit of this expression?
Taking of derivative.
What is the unit of this expression?
Time.
What is the unit of time?
Second. Second hour.
Hour. So the unit of this guy is hour, which is multiplied here.
Okay.
Now this one in the divisor is cancelling with this one which is in the multiplier. So the only leftover is gallon. So the answer is 6 gallons.
Yeah.
So it is not just coming in the air that yes, you got the 6 gallons. You always have to justify your units. Unit system is very important. This dt means time, change in time, and the time is changing in hours. From 0 hour to 2 hours. So dt has a unit of hours. And this guy is changing at the gallons per hour. So it has a unit gallons per hour. So this unit into the unit of time. So this guy cancels with this, that's why it's gallon. So one thing more, which is now we have got from here, that you will always decide the unit of your answer from these two expressions. The unit of this function, f of x, will be multiplied with the
units actually works like if we simply calculate we take all the units of all expression and we simply solve them,
simplify them.
They cut down and there will be a new.
You can simplify them, but
unit.
The rule is how will you finally decide the unit? What is the unit of the function? This function. Put that unit here instead of f of x. The first unit, this is the unit of f of x. Multiply this unit with the unit of displacement. Whether it is the displacement in time or it is the displacement in distance, whatever is dt, this small, it will have a unit. If it is in time, then it will be second, minute, hour, year, month. If it is in meters, it is in terms of the displacement, then it will be meters, feet, kilometers, something like this. And if it is in terms of the weight, then of course it will have a different unit. That unit you will multiply here, the unit of the displacement, small dx or dt. When you multiply them, cancel whatever is cancelling, that will be the final unit.
Right.
Similar, there are some formulas I have written on the pages, you can check them later. If you want to calculate the change in density, then the same formula goes here. What is the change in density? Change in density means change in mass. So it is actually, if you want to know the integral rho dx, it means you are actually calculating the integral m dash of x dx. So they will give you this function, or if they give you this function, the density function, you can always write it like this. Similarly, if you are talking about the population growth, if you recall the advanced mathematics 1, in the population growth there was a function, we said n is the change in population, and we gave it a name. So when they will ask you that what is the total population of a certain region from this to this time, then they will give you a function n dash of t, the change in the population starting from a certain year ending at a certain year. So you have to calculate the change in this, so you can apply the integral on it. Similarly, in terms of the marginal cost, if you recall, what was the formula for the marginal cost? It was, what was the marginal cost, by the way? You know this, in the derivatives we have done it. Remember? Hello. Can you hear? What was the marginal cost? What was the meaning of marginal cost? The marginal cost was, we had solved a very famous question. We said, if the company is producing 500 items at a certain rate, and now after some time they want to produce 501 item, then now they are already producing 500 items, but now they want to increase one more unit into their products, and they want to produce every day. Suppose they want to produce, instead of 500, they want to produce 501 items. Then the change in between the one unit from 500th item to the 501st item, that one unit change in the cost is called the marginal cost, which will affect the company, that only one unit cost, which will be additional when they will increase their products one unit, the additional cost which they have to bear is the marginal cost. And if those people are dealing with the ITE, they will be dealing with marginal cost stuff very much in the future. So marginal cost means that one unit cost which the company has to bear to upgrade their total number of products. So if they are asking you what is the marginal cost, then of course they will give you the number of products which they are already producing and the number of products which they want to produce. In that case, the x1 was 500 and x2 was 501. So you are actually trying to calculate that one unit distance, one unit difference between these two products. You are trying to calculate this in between x1 and x2. 500 is the first point which is they are already producing, and 501 item they want to produce, and the marginal cost function c dash of x dx. This function will be given to you, the total products which they are already producing and the products which they want to produce. So in between, the margin of that additional product is calculated by this integral formula. All these formulas are coming from there. They are coming from the fundamental theorem of calculus, the formula which said that integral f dash of x dx is equal to the f at final point minus f at the initial point. Understand? So you can apply this fundamental theorem of calculus everywhere. Similarly, for example, if you are in a chemical lab, in a chemistry department, and you want to know the concentration of a certain product, then of course that concentration, the change in the concentration of the product will also be calculated by c dash of t at a certain time dt. And what is the initial value t1, what is the final value of the time t2. So you are performing a chemical reaction and you want to know that initially there was a product having a certain concentration and you did the chemical reaction. Now this is the time period when you are doing the chemical reaction. This was the time 1 when you started the chemical reaction, and this is the time, this is now the new product, and this is the time when you finish that chemical reaction. Now you want to know what is the change in the concentration of these two products. So you will start the integral from the initial time at the final time, and you will put that change in the chemical reaction, that thing c dash of t. This function is always given to you. So when you put this, you can get the difference of the concentration of the new product and the old product. Everywhere you can apply this. Similarly, if you go back to the derivative, if you go back to the blood flow problem, the change in pressure, the change in volume, the change in the speed of the blood, all these things can be linked with the fundamental theorem of calculus. The condition is that they will always give you a derivative of something to find the original thing. That's it. If they want you to find the distance, they will give you the derivative of the distance, that is velocity. Okay. So very simple and summary of the inverse process of derivative and integral is that to find the derivative, you are always given a function and you apply the derivative to find the derivative. In case of integral, you are always given a derivative and you will apply integral to find the original function. That is why they are the reverse process. In case of derivative, you are applying a derivative on a function and you get the derivative. In case of integration, you have a derivative already and you apply the integral to go back to the original function. So they go in reverse order, this cycle. Boring?
Yeah, a little bit.
Okay, we have one interesting example, and most of the time I also give this example either in the midterm or in the final exam. So let us solve it here and you can take the benefit of this example in any exam. I don't know whether it will be coming in the midterm or in the final. Okay, it is the same problem, the distance problem, but the function is a little different and we have to figure out where is it positive and where is it negative. In that problem, there were exact values given to us and they told us this velocity is positive and this velocity is negative. So they gave us numerics. Now we have a function of velocity, we don't have numerics. And we have to figure out which part of the velocity was going in the positive direction and which part is coming in the negative direction. So the example says a particle moving in straight line along a straight line x-axis with this velocity function, which is a derivative of the distance. Anyway, the velocity function is given t square minus t minus 6 and the unit is meter per second. Question is find, same question. First one is find the displacement, but the interval is 1 to 4. In between this time interval, find the displacement and find the distance in the same interval. Now for the displacement, I don't care about the negative and positive stuff, right? Right or not?
Yes.
Help
Yeah.
me. For the displacement, I'll just get the answer whatever the function is. So for the part A, I simply need to plug in the integral. The time interval is what? These are the time interval t1 to t2 and the velocity function v of t into dt. So this is the formula which I already know. t1 is 1, t2 is 4, the velocity function is this, t square minus t minus 6 into a dt. A very simple integral. When you solve this integral, the answer is
t3 by 3 minus t2 by 2
minus 9 by 2.
60.
Minus 9 by 2, the final answer. It will be t cube by 3, t square by 2 minus 6t, and plug in the limits.
Yes.
That is your answer. So
Okay.
now what is this answer? I told you already. What is this? What is this number? If you talk about the units, then this function has unit what? Meter per second.
Meter per second.
And this function has a
dt
unit
is second.
a second.
So
So
it
it
will
is
be
cancelled.
meter.
So it means minus
Meter.
9.2, minus 9 divided by
Meter.
2 meter. What is this distance?
It's a displacement. It's a displacement because we didn't
It's
take it
the,
as a positive.
it is the position of the particle from
Yeah.
the starting point.
So
So
it's
whether-
the displacement. Huh?
Yeah, whether it is where now, for example, this is the movement of the particle on the,
Right.
this is on the x-axis,
Right.
not any
Yeah.
not any up down, only on the x-axis.
Okay.
But I have to
Okay.
draw it like this so that you can see the particle is
Yeah.
actually moving like this on the same line.
Yeah. Right.
And then
Yes.
then but I draw it like this for you, so you have to look it from down to bottom. Anyway,
Okay.
then suppose the particle stopped here in the interval, this one, then this distance is minus 9 by 2 meters. The distance from this point to this point. This is the answer for the first part. Now, for the second part, I have to figure out when the particle is going forward and when it is coming backward, when it is going forward. I have to figure out those intervals.
So
Now, look at the original function, which is the velocity function. If I want to check the negativity or positivity of this expression, the better way is if I can make two factors, then it will be easy. I will explain how the factors will be easy. If you make two factors of this using any method, you know completing square or factorization,
Yes.
you know these methods. The two
but
factors.
I have a question that if we are talking about the distance, we want to calculate distance here.
Yeah.
Then why do we care if it's positive and where it's negative? We just take everything positive and then we will calculate. It will give us the distance.
No, it is important. I told you already that it is important to know where is this positive. Now for example, if you don't care about the negative or positive and the particle is moving on the same line, look, it moved like this and it ended here. Now if you don't care about the positive or negative, your answer will be this number. But actually the particle moved a lot in between. So where is that distance?
Take those values.
Where is that distance which he traveled in between it? So you have to figure out that movement in the negative direction. Positive is okay. If the whole movement is positive, that's fine. But there is a negative movement which is not visible here on this line. So you have to figure out. Now if I make the two factors of this, the two factors are, you can do the factorization. The two factors are t minus 3, t plus 2. If you don't know how to do the factorization, tell me.
No, it's easy.
Okay. Now, look, the time interval is 1 to 4. Means I have 4 values. If I talk about the integers, the values for t are 1, 2, 3, 4. If I take t equals to 1 for the first second and put 1 in these two factors, the answer will be 1 minus 3, a negative number, and this is always positive. All these numbers are positive. So this factor will always give you a positive result. When t is equal to 1, you replace t with 1 on these, it will become 1 plus 2, a 3. So okay, let us put here. It becomes, this factor becomes 3 and this factor becomes 1 minus 3, a minus 2. So what is the answer? The answer is minus 6. Means in the first, this second, the answer is negative. Okay, now take the second value, 2. When you put 2, the time it will become 2 minus 3, a minus 1 into 2 plus 2, a 4. Again the answer is negative number. This is negative, this is negative. Similarly, when you put t equals to 3, it becomes 3 minus 3, 0. So answer is 0. It means in between the interval, when the t is between 1 and 3, the answer is negative or 0. And when t is equal to 4, the answer is, put 4 here in the same factors, it will be 4 minus 3, a 1 into 4 plus 2, a 6. It is a positive number. So it means the fourth slot is giving a positive distance and the first 3 slots are giving you a negative distance. So you can split this domain into 2 integrals. This whole thing we did only to check which seconds are creating a negative velocity. So this whole integral is 1 to 4 for this function, t square minus t minus 6, and just now we checked that from 1 to 3 the answers are negative. So you can split the integral from 1 to 3, t square minus t minus 6 dt plus the separate integral from 3 to 4. It gives you t square minus t.
But on the third second, isn't it the 0?
So that's fine, 0. So the problem is creating, the positive distance is achieved after 3. So up to 3, you are getting the negative distance. When you cross the third second, then you are getting the positive distance. So this is already positive. Now, what will we do? What is this? This guy is creating a negative distance and this guy is creating a positive distance. So this is okay. This is okay. But here, no need of mod. But for here, we will put a negative. Just like if you go back, both speeds were written to you in this symbol. But you said this is in the positive direction, you took it positive 40. But with this guy, you replaced it with negative. Remember?
Okay.
So that is why we already checked that this interval is creating negative. So I will add a negative with this expression, and this is positive, so it will remain positive. Now the symbols here change, the calculations will change, that's it. The rest is the same. The integrals you will solve the similarly. It will become minus t square plus t plus 6 dt plus integral 3 to 4 t square minus t minus 6 dt. So you have to solve them separately, and the answer will be 61 by 6 meters. This is the total distance traveled by the particle.
What?
You want a break?
Okay, but wait. Okay, you just removed.
Ask me what?
Okay. What was the answer for the displacement? Can you write?
Minus 9 by 2.
So basically, it's a negative answer. How it can be a negative?
It means
This-
maybe the particle while moving here, maybe it crossed this position towards here.
Okay.
It is moving on the x-axis, so maybe the initial position was this, and the particle also crossed it here, and it reached here, somewhere here. So this is the position between them. But
Okay.
the total traveling on these fluctuations, the total traveling is,
That will always be positive.
yes, that will be a positive number, because how can you say that today I walked minus 60 meter, the total distance. I traveled minus 60 meter towards the university. The people will laugh on you.
Backwards.
Yes, but in some cases, some students, you can say that yes, every day they are walking a negative distance. Every day they are going towards backward, learning nothing and just coming for attendance and talking. Does not talk to me, does not ask me anything. So it means they are traveling a negative distance. Right?
Yeah.